Alrighty, well, welcome back. Well, where we left off before our break is we were talking about replica sets. And I said that the replica sets back over here is going to give us some degree of automation. So Kubernetes is always going to be looking at the desired state. I've got a desired state of I want 2 of these running. If for some reason one died, Kubernetes would automatically, via that controller manager, would actually go ahead and redeploy another one so that my current equals my actual, or my desired equals my current state. Replica sets, however, are not commonly used directly. Why is that? We're using this more automated primitive called the deployment. And this is going to be the most common one that you're going to see. Now, to make sure you understand this, a deployment generates a replica set, which generates pods. See, those last 2 bottom were done for me automatically by using a deployment. So my deployment does have a replicas here. This is going to result in a replica set getting created that the controller loop's going to be watching to make sure that we always have 3 of these pods down here defined. So what are we missing? What else does deployments do for us? Well, remember, cloud native and our new modern apps are about doing updates quickly. Without deployments, we don't have an automated way to roll out an updated version of our code. So we could see down here, I'm deploying Nginx 1.7.9. If my developers came to me and they said, hey, we've got a new version that we want to roll out that has these new features or these new enhancements, I would be able to come to my deployment manifest file, simply change this version out, let's say to 1.8.1, for example, reapply this, and it would automate my rollout for me. Before we had deployments, we didn't have an easy automated mechanism to do this. Now, I need to reemphasize to you, you need to get some core understanding of Kubernetes. This is meant to be just a very rudimentary introduction to Kubernetes and its respective primitives. There's many, many more that we're not covering that you are going to need to have a basic understanding about. So that manifest file would have resulted in this deployment, which gave me 3 of these sitting out here. If I was doing an upgrade, it would go ahead and kill one off, bring up my 1.8.1, make sure that it is operational, and then it would rinse and repeat the rest of the way through the remaining pods. So as I said, the deployments are the most commonly used because they combine pod and replica set declarations into a single manifest. If I had 3 of those pods, how would I actually connect to them? Well, Kubernetes has a primitive type inside here called a service. The service has different subtypes inside of it. This particular type that we're looking at is a load balancer. So hopefully you all have some experience with a load balancer. What are we saying is that we're going to create a load balancer that's going to be connecting to the back-end pods via a front-end IP address. It's going to be listening on port 80, and it's going to be connecting to the back-end workers on port 80. And those workers are selected here via the selector key inside the manifest file. It would, from a picture standpoint, it would look like this. So out here is typically going to be some IP address, okay? Typically something that's available externally that they're going to be connecting to that would in turn connect to one of these two pods in the back end. We're going to talk about how that is being implemented in our vSphere with Tanzu implementation. Just because you've got pods running and they're going to have IP addresses, do I necessarily want somebody maybe to come through on 8080, or do I want this pod to be able to talk to that pod? You can control that inside Kubernetes using these things called a network policy. Network policies, very simply put, it's a definition of firewall rules. So in this particular case, I'm creating both ingress and egress rules, and I'm saying I'm allowing an ingress from this particular IP range or from pods selected like this on port 80. And I'm going to allow any of the pods that I've selected here to actually egress out. So what traffic is allowed out? They're allowed out to only this IP block on port 80. So network policies are a way for us to define firewall rules for our pods. Typically, what's going to happen is there's going to be a series of these manifest files that your developers are going to be developing. They're going to be testing them in their test silo of a Kubernetes cluster, making sure their application works. And then from there, the application's typically going to get, quality assurance, or QA is going to go take a look at it, make sure everything's good. Typically, my security people will probably look over this file, give it a thumbs up, a thumbs down, tweak it, etc. And eventually, all this is going to get promoted into production. We're going to take these files and apply them, and our applications are going to be deployed as a series of containers, and that's what our business users are going to be connecting to. Pods, and literally anything that I deploy inside Kubernetes, are actually running inside of this construct called a namespace. So you have by default a default namespace, but typically what we're going to do when we create a cluster is we're going to create a series of namespaces, and you can kind of think of them as a silo. Maybe I'll create one Kubernetes cluster that I'm going to have a group of developers working in. I'll create a series of namespaces, and I'll give one namespace to developer A, I'll give another namespace to developer B, and another namespace for developer C, and they'll each respectively work in their namespaces. Later, maybe in my testing Kubernetes cluster, I'll create an additional set of namespaces for different testers to use to test the applications they're looking at. And then maybe when I get into production, I'll create another Kubernetes cluster, and I'll create respective namespaces for things like, okay, this is my shopping cart namespace. This is my RMA namespace. This is my customer service namespace. So you'll create the different namespaces to silo respective applications in. It's a boundary. We can also use that boundary to do authorization as to who gets access to it. And we can also use it to cap resources. So how much CPU, how much RAM, how much disk space are they going to be able to allow to use inside of it? Resource pools are probably the closest thing that we as a vSphere administrator understand. And their namespaces are very similar to that as well. You could see here that the namespaces do span across the various respective Kubernetes nodes, but they are constrained inside of a single Kubernetes cluster. What's the typical workflow like? When somebody is done, we already went through this up here from the developer's workstation. right? My developers are walking through, they're developing their app, they're using their build command, and they're spitting out a Docker image that they're going to use. From there, the next step they're going to want to do is they're going to want to test that their container can run inside the Kubernetes runtime environment. So they're going to be using the kubectl command, and they're going to actually be the ones constructing those initial manifest files that we just went through. They would then use the kubectl command, and they would connect to a Kubernetes cluster that you've defined and you've given them authorization to, specifically into a namespace into that Kubernetes cluster. And from there, they'll deploy their containerized workload. The API server is going to, one, post the desired state to etcd, but it's going to then also talk to the scheduler to figure out which one of the Kubernetes worker nodes it should be deployed on. He'll give us an answer. We'll talk to the kubelet that's running on that worker node. The kubelet would construct a pod for the container to be run in. It would then hand it off to the container runtime engine, this case Docker, which would in turn pull that image down and deploy that container inside that pod. Now, where do we come into play? Well, if we look at the line here, right, on this side of the line is the infrastructure we're going to be responsible for. On the other side of the line, that's your developers. They're setting up their workstation. Yes, we are going to have to support them. And typically, we're going to have different Kubernetes clusters set up. I'm only showing you one, but it's not uncommon to have, a dozen different Kubernetes clusters, different versions, different use cases. I might have one Kubernetes cluster that, is dedicated for the developers to use. And there might be a 1.15 version, a 1.16 version, and a 1.17 version because they're testing their container on different versions of Kubernetes. So with that overview, we've gone over the importance of Kubernetes. It is our orchestration engine that is going to be solving running multiple containers across multiple container runtime environments or container hosts. We've gone over the basic architecture. Again, the main pieces to know is we've got our control plane VMs, and then we've got our worker VMs where there are pods in our containers are actually running at. And we went over the basic workflow that's involved to do Kubernetes. So that concludes this module. Why don't you go ahead, take a break, and join me back for the next module where we're going to be talking about Tianzu architecture. Thanks, and I'll see you soon.